Hello students, in our previous class I have discussed about the physical characteristics of group 17 elements. Mainly I have discussed about the halogens, that is fluorine, chlorine, bromine and iodine. After that we have also discussed about the synthetic procedure of the fluorine by using the Moisa process, and then the reactions of the fluorine, and finally the uses of the fluorine. After that we have also discussed about the anomalous behavior of fluorine, and then the hydrides and the oxides of the halogens. Now in our today's class I will mainly discuss about the chlorine, that is Cl2. Okay, so after the discussion of hydrides and oxides, now we are going to the reactivity of the halogens towards metals. Suppose I am taking the magnesium. Magnesium is a solid, and when it reacts with the halogen, I have written here as X2, then it will form the MgX2, that is MgF2 or MgCl2, MgBr2 or MgI2 solid. So the ionic character of these halogens that actually shows in the order, that is Mf greater than Mcl greater than Mbr greater than Mi. So out of the metal halides, the metal fluorides is more ionic in nature due to the high electronegativity of the fluorine, and the trend of the electronegativity is going as fluorine greater than chlorine greater than bromine greater than iodine, and for that reason the ionic character also showing the same trend. The SnCl4, PbCl4, SbCl5, UF6, these are also the metal halides, and they are more covalent than the SnCl2, PbCl2, SbCl3 and UF4 respectively. So which means that if the oxidation number of the metal is going to increase, then in case of the metal halides the covalent character is increasing. Okay, so that is the reactivity towards the metals with respect to the halides when they form the metal halides. Next topic, that is the reactivity towards the other halogens. These things I have already discussed when I have discussed about the interhalogens. Interhalogens means like IF7, BRF5. Here on that time in our last class, you just check one time, I have told about the interhalogens compound. So today we are mainly going to the new topic, that is the preparation of the chlorine. In our last class we have discussed about the synthesis, reaction and uses of F2, and in our today's class mainly I will discuss about the synthesis, reaction and uses of the Cl2, that is chlorine. So first of all, how can we prepare the Cl2, that is chlorine? When manganese oxide, that is MnO2, reacts with the concentrated HCl, and if I will heat the mixture of MnO2 and concentrated HCl, then we can get the chlorine gas, that is along with the MnCl2 and water. Another process is also there, that is suppose I have sodium chloride, and when it reacts with the MnO2 in presence of concentrated H2SO4, then we will get the Cl2 gas along with sodium hydrogen sulfate or sodium bisulfate and manganese chloride. Okay, so that is the second process. The third process is also there. Suppose I have the potassium permanganate, and when the potassium permanganate reacts with the HCl, means concentrated HCl, then it will give the chlorine gas along with KCl, MnCl2 and water. So these three processes are there by which we can synthesize the Cl2 gas. Next, the famous processes are also there. One is the Dicons process, and one is the Downs process. So these are the industrial processes, and by using these processes we can synthesize Cl2 in industry. So first of all I am discussing about the Deacons process. In Deacons process, suppose I have the hydrogen chloride, that is HCl, hydrochloric acid is there, and first we have to place it in air. Okay, and so when the HCl and O2 both together react in presence of cupric chloride, that is the CuCl2, at 723 Kelvin temperature, then we will get the chlorine gas. Okay, so that is the Deacons process. Another process, that is the Downs process, is also there, and this Downs process, that is mainly the electrolytic process for synthesizing the Cl2. Everybody we know about the brine solution. The brine solution is the concentrated NaCl solution. Okay, so in this process we have to electrolyze the brine solution, that is the concentrated NaCl solution, and when we electrolyze the brine solution, then the Cl2 gas is liberated at anode, and in this process we are mainly using the anode as carbon rod and iron as the cathode. Okay, so that is the electrolytic process, that is also known as the Downs process. So this is all about the synthetic procedure of the Cl2 gas. Next we are going to the property of the Cl2 gas. The Cl2 gas, that is 2 to 5 times heavier than air. Okay, the Cl2 gas, that is 2 to 5 times heavier than air, and it can be liquefied easily into greenish yellow liquid which boils at 239 Kelvin temperature, and the Cl2 gas, that is soluble in water. Okay, so these are the physical properties of the Cl2 gas. It is heavier than air, that is 2 to 5 times heavier, and it can be liquefied easily, and it is soluble in water. Next I am going to the reactions of the Cl2. The reactions with metals. First of all, suppose I have metals like aluminium, and when the aluminium reacts with the Cl2 gas, it will form AlCl2, that is aluminium chloride. And similarly, when the sodium metal is there, and when it reacts with the chlorine, it will form NaCl, that is the sodium chloride. Similarly, when the iron is there, and when the iron is reacting with the Cl2, it will form the FeCl3, that is the ferric chloride. Okay, so these are the reactions with the metal, and the Cl2 gas, it also reacts with the non-metals also. Okay, so for example, I have suppose I have the non-metal like phosphorus or sulfur. When the Cl2 gas react with the phosphorus, then it will give PCl3, that is phosphorus trichloride, and when the sulfur, that is also non-metal, and when it reacts with the Cl2, then it will form S2Cl2, that is disulfur dichloride. Okay, so chlorine, that actually reacts with metals as well as non-metals in this way. The chlorine gas, it has also great affinity for hydrogen. Okay, everybody know about the HCl, so that is the reason of a great affinity towards hydrogen of Cl2. So H2 plus Cl2, it will form HCl. Suppose I have H2S, and that is hydrogen sulfide gas, and when it reacts with Cl2, it also forms the HCl along with sulfur. And if I have any type of hydrocarbon like C10H16, and when it reacts with chlorine, then we will get the HCl. So in this way we can observe that the Cl2 or the chlorine in Cl has a great affinity towards hydrogen, so it can form HCl very easily. Then we are going to the another reaction part, that is the reaction with ammonia. So how the Cl2 gas reacts with the ammonium. These reactions are very important for your exam also. You can see in your last previous year question paper that this portion is very important. So how Cl2 reacts with the ammonia. If I have excess amount of ammonia and when it reacts with the chlorine, that is 8NH3, that is in excess amount ammonia, and when it reacts with the chlorine, that is 3Cl2, then it will form ammonium chloride, that is NH4Cl, along with nitrogen. And when the chlorine is excess and ammonia is in minimum amount, that is NH3 plus 3Cl2, then it will form NCl3, that is nitrogen trichloride along with HCl, and that NCl3 that is explosive in nature. Okay, so these are the two part. In the first reaction we have observed that when the ammonia is in excess amount, and in the second part we had seen the chlorine that is in excess amount. So in these both cases, in the first case the ammonium chloride along with nitrogen is formed, and in the second case the explosive nitrogen trichloride along with HCl are formed. The addition compounds are also there, so chlorine can form the addition compounds also. For example, when the carbon monoxide is there and when it reacts with the chlorine in presence of sunlight, it will form COCl2. Okay, so COCl2, that is actually known as the phosgene, and similarly when the NO gas is there and when it reacts with the Cl2, it will form the NOCl. Similarly when the SO2, that is the sulphur dioxide is there, and if I will react that sulphur dioxide with the Cl2, then it will form SO2 Cl2. So these are known as the addition compound or the adduct, the formation of the adduct. So when the CO reacts with the Cl2 in presence of H2, it will form CaCl2, that is phosgene. When NO reacts with the Cl2, it will form NOCl, and when the SO2 reacts with the Cl2, it will form SO2 Cl2. The chlorine also react with the alkali. Okay, so now we are going to that part, that how the chlorine gas reacts with the alkali. So suppose I have NaOH, and that NaOH is cold and diluted, and when that cold and diluted NaOH reacts with the chlorine, it will form NaCl, NaOCl and water, that is sodium chloride, sodium hypochlorite and water. When the hot and concentrated NaOH is there and it reacts with the Cl2, it will form NaCl, NaClO3 and water, that is sodium chloride, sodium chlorate along with water. So these two reactions are also very important for your exam. So here also the two things are there. The first one is the cold and diluted NaOH, and the second one is the hot and concentrated NaOH. Okay. Next, if I have the calcium hydroxide, so that is also the alkaline earth metal, and that alkaline earth metal hydroxides, okay, that is also known as the dry slacked lime, and when it reacts with the chlorine, it will form CaOCl2 along with CaCl2 plus water. So that CaOCl2, that is actually the bleaching powder. So in this way we can also synthesize the bleaching powder. Means when the calcium hydroxide reacts with the chlorine, then we will get the bleaching powder, that is the CaOCl2 along with the CaCl2. Okay. So here I had written the composition of the bleaching powder, that is the composition, that is CaOCl2, CaCl2, CaOH2 and water. So that is the total composition of the bleaching powder. Previously we know that the bleaching powder, that is CaOClCl. Okay, but actually in bleaching powder so many compounds are there, like CaOCl2, CaCl2, CaOH2 and water. So that is the main reaction for synthesizing the bleaching powder for industrial purpose. Okay, so this reaction is also important for synthesizing the bleaching powder. Next, the very important property of Cl2, that is the bleaching action. Okay, so it can bleach the colored material also. The Cl2 water, means the chlorine water on standing, loses its yellow color due to the formation of HCl and HOCl. HOCl gives nascent oxygen, which is responsible for oxidizing and bleaching property of Cl2. It is permanent bleaching. That point is very important when you use the chlorine water, and first of all it loses its yellow color due to the formation of HCl and HOCl. So here I have written the reaction. So first of all, Cl2 and water, it will form the HCl and HOCl, and then again the HOCl dissociates into HCl along with the nascent oxygen. That's why 2HCl plus nascent oxygen I had written, and that nascent oxygen, that is the main responsible person, okay, means the main responsible element for oxidizing and bleaching property of Cl2, and that bleaching is permanent in nature. So next I am going to the oxidizing power of the Cl2. Suppose I have H2S, and when that hydrogen sulfide, that is H2S gas, reacts with the chlorine, then it will form HCl along with the sulfur. So here you can check that the Cl2 here, that is in 0 oxidation state, and here the HCl, that is in -1 oxidation state. So here reduction is happening, and in case of the sulfur, the oxidation is happening. So it helps in oxidation for the other elements. That's why here I have written that is the oxidizing power of the Cl2. Okay, so Cl2 is a powerful oxidizing agent. In another reaction we can see that when the ferrous sulfate, suppose FeSO4 is there, and when it reacts with the concentrated sulfuric acid in presence of Cl2, it will form Fe2SO4 along with HCl. Okay, so here the Cl2, again here the oxidation number is 0, and in case of the HCl the oxidation number is -1. So here the reduction is happening, and in case of the ferrous, means in case of the iron, here the oxidation number is +2, and here the oxidation number is +3. So here in case of the iron the oxidation takes place. So here Cl2 acts as a oxidizing agent. In the another reaction we can also observe that suppose I have Na2SO3, that is the sodium sulfide, and when it reacts with chlorine and water, it will form Na2SO4, that is the sodium sulfate, and here also the oxidation takes place in case of the sulfur, and Cl2, it actually reduced to the HCl. So here the sulfur is oxidized, so chlorine, that actually acts as the oxidizing agent. It is, I think, is it clear? It is clear to all of you. So I am going to the another reaction. Suppose I have the sulphur dioxide, and when the sulphur dioxide reacts with the water in presence of Cl2, it will form H2SO4. Here also the oxidation takes place in case of the sulphur, and the reduction takes place in case of the Cl. So that reaction also proves that the Cl2, that is the chlorine, has oxidizing ability. Next reaction, that is the, suppose I have iodine, and when that iodine react with the water along with the Cl2, then it will form HiO3 along with HCl. So if I will look to the iodine, here iodine, the oxidation number is 0, and in case of the HiO3, what is the oxidation number of iodine? H is +1 and oxygen is 3, so -6, that is +1. So here the oxidation number of iodine, that is +5. Okay, so here also the oxidation is going on, and in case of the Cl2, that actually form the HCl due to the very high affinity towards the hydrogen. It always forms HCl. You can look in all the reactions HCl is formed. So here Cl, that actually reduced to HCl. So Cl2 has the oxidizing ability. It can oxidize I2 to HiO3, that is 0 to +5 oxidation state. So these are the reaction part for the Cl2. Next I am going to the uses. What are the uses of the Cl2? Okay, what are the uses of the Cl2? I had already said about the bleaching action. So bleaching paper and rayon, the Cl2 is used. In case of the manufacturing of dyes, the Cl2 it can be used. For synthesizing drugs, CCl4, CHCl3, DDT, etc. The Cl2 is used widely. In case of preparation of poisonous gas, that is phosgene, that is COCl2, tear gas, mustard gas, I had written the structure of the mustard gas here, and as disinfectant, sterilization of drinking water, the Cl2 is used very widely. Okay, so this is all about the chlorine's synthetic procedure. Next, we have already discussed about the reactions parts of the chlorine and what are the uses are there in case of the Cl2. Next, I am going to the HCl. That is also a very important part. HCl, how can you synthesize the HCl? Suppose I have NaCl and when it reacts with H2SO4 at 420 Kelvin, it will form the sodium bisulfate along with the HCl. That actually in the form of the gas, because the temperature is very higher, that is 420 Kelvin. Next, NaHSO4, when the sodium bisulfate that actually forms, and again when it reacts with NaCl at 823 Kelvin, it will form Na2SO4 along with HCl. So, and that HCl gas that can be dried by passing through the concentrated H2SO4, as because everybody we know that concentrated H2SO4, that is the dehydrating agent. So if I will pass the HCl over the concentrated H2SO4, then HCl is dried. So in this way we can synthesize the HCl very easily. Next, the property and the reactions. Property and the reactions of the HCl. HCl is colorless gas and it easily liquefied to colorless liquid, which boiling point that is a 189 Kelvin, and it freezes to white crystalline solid, and which freezing point that is 159 Kelvin, and that is extremely soluble in water. And next thing is that is the aqua regia. That is also important. What is aqua regia? Aqua regia, that is the 3 parts of concentrated HCl and 1 part of concentrated HNO3. If I will mix the 3 part of concentrated HCl and 1 part of concentrated HNO3, then it will give the aqua regia, and that aqua regia that actually dissolves the noble metals. So that is very important, the aqua regia. So here I had written the reaction parts, means how the noble metals are get dissolved in aqua regia. Suppose I have gold and H plus, NO3 minus and Cl minus is there, means NO3 minus that actually comes from the HNO3 and Cl minus that actually comes from the HCl. So when these react, it will form AuCl4 minus. Okay, AuCl4 minus along with NO and water. Similarly, another noble metal, if I will take the platinum, and when the platinum reacts with the H plus, NO3 minus and Cl minus, means when it reacts with the aqua regia, it will form PtCl62 minus plus NO plus H water. Okay, so that is the reactions of the noble metals with the aqua regia. Next, HCl decomposes salts of weaker acids. Suppose I have sodium carbonate, that is Na2CO3, and when it reacts with the HCl, it will form 2NaCl plus water plus CO2. So HCl decomposes salts of the weaker acid. Okay. Similarly, suppose I have the sodium bicarbonate, and when it reacts with the HCl, then it will form NaCl and water and CO2. Similarly, if I have Na2SO3, that is the sodium sulfide, and when it reacts with HCl, it will form NaCl, water and SO2. So these reactions easily shows that HCl decomposes the salts of the weaker acid. Another reaction I have written here, that is when suppose I have the iron, and when iron mainly reacts with the HCl, it will form FeCl2 plus hydrogen. Okay, so that FeCl2, that is actually ferrous chloride, and that ferrous chloride is not very stable. So hydrogen liberation prevents the formation of the FeCl3, but that FeCl2 that actually oxidizes to FeCl3 in every time. But if I will synthesize the FeCl2 in this way, means when the iron reacts with the HCl, then FeCl2 forms along with the hydrogen, and on that time the FeCl2 cannot be oxidized to FeCl3, as because the hydrogen is liberated here, and hydrogen liberation prevents the formation of the FeCl3. Okay, so in our today's class I had mainly discussed about the synthetic procedure of chlorine, the important reactions of the Cl2, and then I have also discussed about the uses of Cl2, and finally the synthesis of HCl, what is aqua regia, how aqua regia reacts with the noble metals. So these things are very important for your exam. So I had discussed these things, and then in our next class I will discuss about the oxo acids of the halogens, okay, and the other things I will discuss in our next class. So for today, thanks to all of you.